Okay, let's take a look at this question now. Another of these circular motions. Now, similar to what I've done in the previous video, and in this one, I have a bit of a difference here. Rather than having, a sphere inside, I mean a hollow sphere in which an object is rolling like that, we actually have we actually have a point in which a string is fixed and then it is being rolled over extended like that, in such a way that this thing keeps oscillating. And then when it reaches here, then the string becomes slack, which is highly important for this part of the question. But it says that a particle of mass m is attached to one end of a right distance to a string of length a, the other it is attached to point O. It is such that OA equals to A, which means its radius makes an angle A alpha with the upward vertical where tan alpha is this one. It is rotated downwards, be perpendicular to string, and then the string becomes slack when it comes here, which means the tension is zero. However, that's going to be something you're going to need in a bit. For now, I have to make, first of all, because we have a velocity given and we can easily find a height. So what's the different heights that we need? We need a height here. We need a height here and we need a height here. So what is this little height now? And this is another height that we need. Now, keep in mind that this is 90 degrees. How? It is rotating 270 degrees. In order to make a complete rotation back towards A, it has to be 360 degrees. So the remainder is obviously 90. So if it's 90, if this is 90, this is alpha, this is going to be 90 minus alpha. And if this is vertical, this is horizontal, this is 90, this is 90 minus alpha. So the remaining one is alpha. Absolutely necessary for B. If this length is A, then this whole thing is A sine alpha. And if this is A sine alpha, this is 90 degrees, this is 90 minus alpha. And therefore, if this is A, then this means that this portion is A sine 90 minus alpha or A cos alpha. If this is A cos alpha, this is A sine alpha. So it means it's going to be this one here equals to A cos alpha minus A sine alpha, actually. Yeah, it is A sine alpha and it is A cos alpha. So the change here is A cos alpha, A sine alpha minus A cos alpha. So it kind of looks like this. If tan alpha is this one, then sine alpha is 13 by 5, no, 12 by 13, and cos alpha is 5 by 13. Opposite by adjacent, opposite is at the top, and the bottom is hypotenuse. So for hypotenuse, we just square both of these and then sum them together. So because of this, we now have this one. So A sine alpha equals to 12A by 13 minus 5A by 13 equals to 7A by 13. So it means that the change in particle height is 7A by 13. Now, because I have a velocity, I can first of all start off with the energy conservation. At this one, we have half MUA, half MU squared equals to, because it's gaining a height, it's going to be half MVV squared plus mg 7a into 7a by 13. So we need expression for bb because I want to use that in the next part. So we have half mu squared equals to half mbb squared plus 7mga by 13. So we have here bb squared. Okay, we can cancel the m's out because we don't need it in the second line. We will need it in the first line. Otherwise, they're going to cut a mark. So we have u squared minus 14 Ag by 13. So next up, we need to deal with the Newton's law. Summation of forces at the point B equals to only the mg cos theta, because it is this direction and it's trying to move in this direction. In the direction the velocity is moving, we consider that to be sine usually. If this is my angle, then this is supposed to be my, if this is mg, then this is supposed to be mg sine alpha. Let me show you. If this is alpha, this is mg, then this is supposed to be mg sine alpha. And because it's here alpha, so we write here mg sine alpha or equals to 12 mg by 13. We have here at point B, we have mv squared by r or a equals to 12 mg by 13. So we can cancel the m's out. So we have here e square minus 14 ag by 13 equals to 12 ag by 13. So u square equals to 26, 14 plus 12, 26 ag by 13. So we have u square equals to 2 ag. Same thing as the top. Now in the next part it says find the maximum tension in the string as the particle moves from A to B. That's definitely here. All right. When it is completely vertically downwards, due to weight having most of the due to weight having complete effect on the forces that are acting on the particle at point A, when a particle there, what happens is that due to this high effect of force downwards, the tension will have to be such that the thing actually stays there in such a way that the tension actually has to be as high as possible. So my summation here. So I'll have to consider a point C at the bottom. And at this point, what happens is that this is the A cos theta, and this entire length A will have to be decreased once it reaches here, because what happens is that when it reaches bottom, obviously it's losing height, so it loses GPE. So it means that initially there was a GPE. So I'm first of all going to use the energy conservation equation again. So we have half mu squared plus mga plus a cos theta, no, a cos alpha, alpha isn't it? Yeah, a cos alpha. This equals to um, half mvc squared. At bc squared, it loses all that part. The change in GP is this one. So it means that bc square equals to u square plus 2g a plus a cos alpha, 1 plus a plus 5a by 13, or it's going to be 18a by 13. So then what we have is the summation of forces at C. This equals to the tension force which acts upwards this time towards the point O, this plus mg. So we have here mbc squared by a mbc squared by a equals to t plus mg. So after that, what we have to do is that we have, okay, let's see what we can do. This is equals to 36 mga, hold on, u square equals to 2ag plus 36a by 13. So it means that we have 26 plus 36 62A by 13. So after that, what we will do is that in this case, I have to replace BC square with that. And because I have A at the bottom, which means I only get 62M by 13 equals to T plus mg. Oh wait, it's actually not plus, it's actually minus. And there's supposed to be g there. Then what I have here is T equals to 62 mg by 13 plus mg. So it means that I have to add 13 at the top like this. Therefore, what we get is T equals to 75 mg by 13.